This video is about another fundamental concept of thermal physics, latent heat. Say we have a cup of water. This is the cup. This is the water. Say the cup is put above a heat source. So energy is transferred to the cup through heat. What will be the effect of transferring energy to this cup? The temperature of the water will rise gradually. When the temperature equals the boiling temperature of the water, the supplied energy will start to break the bonds between the molecules of the gaseous state, and this bond breaking allows the molecules to move further apart in gaseous state. So, at this moment, some amount of water will be transformed into vapor. This is an example where energy exchange does not result in change in temperature, rather a change of phase occurs. When discussing two phases of a material, we will use two terms: higher phase material, material that exists at higher temperature, and lower phase material, material that exists at lower temperature. For our example, vapor is higher phase material and water is lower phase material. Now, the initial mass of the higher phase material in this case is 0. Say, after transferring Q energy to the system, that is to the cup, the mass of vapor becomes mf, where mf is greater than 0. So, the change in mass of the higher phase material, that is the change in mass of vapor, delta m equals mf minus 0. Now, if the initial mass of the vapor is mi, then the change in mass of the higher phase material, delta m equals mf minus mi. Latent heat is defined as the transferred energy per unit change in mass of the higher phase material. So, latent heat L equals Q divided by delta M. Now, why this is called latent heat? Because the transferred energy does not result in a temperature change. Some common examples of latent heat are latent heat of fusion, latent heat of vaporization, latent heat of condensation, and latent heat of solidification. Latent heat of fusion, LF, is the latent heat when the phase change is from solid to liquid. Latent heat of vaporization is the latent heat when the phase change is from liquid to gas. Latent heat of condensation. Lc is the latent heat when the phase change is from gas to liquid. Latent heat of solidification. Ls is the latent heat when the phase change is from liquid to solid. Numerically, Lv equals to Lc and Lf equals to Ls.